When you step outside, the ground beneath your feet feels permanent. It's solid rock, dirt, and concrete, holding entirely still while we move across it. This is a cross-section of our planet, and it shows a different reality. If you map the distance from where you are standing right now down to the dead center of the Earth, it is a 6,371-kilometer drop. The sudden shaking of an earthquake, or the slow drift of the magnetic North Pole, are impossible to explain if you only measure what is happening up here in the daylight. To figure out how this machine operates, we have to go down. We are going to take a linear, uninterrupted dive from 0 kilometers all the way to the absolute center. Mapping that invisible, high-pressure environment is the only way to understand how the surface we live on remains habitable. Our starting point is the crust. Depending on whether you are standing on a continent or floating over an ocean, this outer rock shell is only 5 to 70 kilometers thick. Out of a 6,371-kilometer journey, that 70-kilometer shell is essentially a layer of paint. Past that boundary, we hit the mantle. The temperature instantly spikes, climbing past 1,000 degrees Celsius as the rock transitions from cold and brittle to a state that is much more pliable. The mantle is massive. It spans approximately 2,900 kilometers in depth, taking up the vast majority of the planet's volume. The primary mechanical driver inside this space is a process called convection currents. Intense heat radiating from below causes the mantle to warp, rise, and sink, behaving as a churning fluid. As it circulates, it drags the crust's underside, physically pushing and pulling the tectonic plates right above it. The ground we inhabit is actually floating on top of a massive, constantly moving thermal engine. At 2,900 kilometers down, the rocky mantle ends. We cross the boundary into the outer core. This layer is a 2,200-kilometer deep ocean composed entirely of liquid iron and nickel. Thermal energy creates rapid, swirling currents in this superheated liquid metal, trapping an immense amount of kinetic energy deep within the planet. Because iron and nickel are highly conductive, their movement generates a massive electrical current, which creates Earth's magnetic field. This magnetic field extends far into space, functioning as an invisible shield that deflects solar radiation away from our atmosphere. We hit the final major boundary at 5,150 kilometers, the inner core. The temperature here is over 5,000 degrees Celsius, roughly the same as the surface of the sun. At that heat, metal should be completely liquid, but this 1,220-kilometer radius sphere is actually a solid ball of metal. These vector arrows represent the weight of the entire planet pressing down on this single point. The pressure reaches over 3 million atmospheres, which is high enough to force the iron atoms into a solid state despite the heat. The center of the Earth is defined by this exact balance, 5,000 degrees of heat versus the crushing weight of thousands of kilometers above. We have reached exactly 6,371 kilometers deep, the absolute center. Pulling back to see the full cross-section shows how these distinct layers interact as a single unit. The solid inner core provides the physical foundation for the outer core's movement, which generates the magnetic shield, while the mantle cycles the heat that keeps the surface in motion. Up here on the surface, our environment feels tranquil, but that stability is only possible because of the massive volume of moving metal and rock below us. The high-pressure activity buried thousands of kilometers away from the sun is the exact engine required to make life on the surface possible.